Welcome to Tell Me More, Coffee with Chris Yip, the official podcast of the Faculty of Applied Science and Engineering at the University of Toronto. Each month, I sit down with someone from our vibrant global community to talk about what places them at the heart of designing bold solutions for a better world. You'll meet alumni, students, and professors who are making a difference across a range of fields, including some where you may not expect to find them. My guest today is Andrew Forde. He's a double graduate of our faculty, having completed his undergraduate in material science and engineering and his PhD in industrial engineering. Throughout his career, he has held several key technology roles at organizations including Boston Consulting Group, IBM, and Deloitte. Earlier this year, he was appointed head of AI research at KPMG. Andrew, welcome to the podcast.
Thanks for having me.
Hey, looking forward to this conversation. We've chatted a ton on a whole bunch of different mechanisms, whether it's over lunch, whether it's on LinkedIn, whether it's just random conversation, text, constant, every possible mode of communication. Now we're actually doing it in person, which is kind of fun.
Which is awesome, yeah.
You're now in the AI space. Classically, that's kind of a comp eng, CSE type thing, but you did start in material science and engineering, one of our smaller, tiny but mighty departments in engineering. Why'd you start there?
Originally, when I wanted to come into engineering, it was to get into aerospace. Aerospace was what I thought was my calling. I was fascinated with airplanes, aerospace, space exploration ever since I was a kid. And so coming to U of T, that was sort of the mindset. And then considering that, I was looking at what are the areas of aerospace that would be of interest to me. And material science is obviously for a whole bunch of reasons, a great entry point. And then it also gave me this sort of, just in case I change my mind, a lot of things were happening in the sort of quantum mechanics, nanotech world, which also lands beautiful with material sciences. So for me, it was, okay, I can either find a path in aerospace, or perhaps I can, if I'm more interested in the frontier research side, I can be close to what's cutting edge and happening. So that's how I landed.
Did you PY?
Yes.
You did?
I did.
So where did you PY?
The Independent Electricity Service Operators of Ontario.
So how did that tie to material science though? Or was it just, this is just another part of engineering?
It was just another part of engineering. But the one thing that surprised me in material science is that it's very interdisciplinary. And so a lot of thermodynamics, a lot of chemistry, a lot of organic, inorganic, a lot of calculus, all these things. So the IESO role wasn't necessarily a specific material science role, but grid optimization, battery storage, all these sorts of things played a nice little caveat into the material science space.
And it all comes down to materials too, right? You sort of saw battery science in terms of electrodes and storage and all this sort of. So again, material science can be foundational to all disciplines.
I actually believe, and not because I'm a graduate and biased, but I actually think it's one of the best fundamental engineering degrees to get because it's foundational to so many other things and applicable to so many other spaces. And
there is a really strong tie to AI and material science, especially at U of T right now. We have the Acceleration Consortium, which is all about AI for materials discovery. And the partnership is really between chemistry and material science and engineering. I'm going to say you were kind of the founder, the catalyst for this.
I'll let you say that. But I think it's more that I stumbled into it. And I'm sure we'll get to this a little later, but the connection between foundational understanding of systems, which a lot is sort of part and parcel of material science, plays a role in how you look at systems regardless of what they are.
During your MSc days, even though you went to this other sort of space in the energy space, you also did have a job at NASA. Is that right?
Yes.
Yeah.
Yes.
So what was that like?
So surprisingly, it was for ceramics, the heat shields. And so as folks may or may not know, one of the largest limiting factors is friction in hypersonic flight. And when you start getting, in excess of 36 to 150,000, feet a second. It's these
a little fast.
A little fast. The limiting factor is not propulsion. JPL has done a great job in figuring a lot of that out. It's in not disintegrating as you're hurling through whatever medium, space or the atmosphere or air or whatever it might be. So the research group was focused on looking at ceramics, coming up with new ceramics, new properties, etc. At the stage that I did that work, I was just a little data monkey in the corner. Like the real scientists were doing the scientific work. I was supporting getting coffee and doing all the things that I needed to do. But
Probably doing more than getting coffee.
a little bit more on the data and computational side. What I learned from them and that group and the work done was really twofold. One is what the discipline of science really looks like. And that was really important for a myriad of reasons. And the second is that no matter how smart you think you are, you are not very smart. and so it was humbling from that perspective, especially as like a new engineer that thinks that you understand a lot, to recognize that, no, you're really just at the beginning of your journey. And then I guess the unintended consequence of that time was also for me personally that fundamental research would not be my calling. I wanted to be more engaged with people, with decisions. It's not like the movies. That's another thing U of T, also taught me, which was when you come to a lab, it's not what the movies show you it is. You're usually in a basement.
Wait, you're not wearing a white lab coat?
Yeah,
the little bubbling beakers of blue stuff?
Precisely. And so all that to say, it also showed me, I guess, where I felt I would be able to have more contribution in my career. Yeah.
So how long were you at NASA before you transitioned to consulting?
Just under a year.
Just under a year. So you lasted. That was
quick.
enough.
Yeah.
Enough time spent in the corner analyzing data.
Yeah.
And it's like, okay, we're going to move into the consulting space. Where I guess it's a cool opportunity, right? You get a chance to, people come to you to ask questions, but you're also there to ask questions.
Exactly.
So Boston Consulting Group, IBM, Deloitte, all in different sectors when you went to those different places?
All in technology.
Okay.
So all in technology strategy, digital transformation, office of the CIO, like all in the technology realm.
The IT space.
The IT space.
Okay.
The only caveat being that as you're more junior, you might get pulled into projects outside of that, just for availability. What's literally get working, get busy.
You put your hand up. And
Exactly.
There you go.
So you do
Andrew's free.
A lot of volunteering, a lot of voluntolding.
Right.
But yes, primarily always in the technology space.
Did you find it challenging to be in being asked to do different things?
It was challenging, but it was a challenge that I actually enjoyed.
Right.
And that's why I've stayed in consulting. Like, to be fair, we have this little vantage, which is if you stay in consulting for more than 3 years, you're probably going to stay forever. I really enjoyed the ability to work across a myriad of problems, different industries, different sectors, different organizations, different people, like the diversity of having sort of like another degree in the period of time that you're forced to get up to speed. And this is before all of the sort of search tools, Gen AI tools, right? So when a partner or a senior leader asks you to figure something out, you had to go back to your first principles.
Right.
You had to go and do the research. You had to go to, I used to come to U of T's library and use my T card to try get
Sneak
books.
back in.
Exactly.
Okay.
Exactly. And so I think that was foundational.
And you also moved between consulting firms as well, right? So was it a question of also scale of the problems and also duration of the jobs that you were looking at?
I think I approach consulting my career generally as you come into a new environment, you spend 3-4 years, you learn as much as you can, and then you move to another to get the same breadth of understanding. And so I think early in my career, I'd made that decision that I would try to move around to get, because the sorts of problems that you see will also change based on the firm. IBM would get a specific kind of problem generally. Deloitte would get a specific kind. BCG would get a specific kind, et cetera. So it gave me an opportunity to really get some depth, which now in sort of the senior years of my career has paid off.
Well, I think it's great to have that broad perspective, right? That opportunity to see different sectors, different cultures, I guess, within the companies themselves, the different types of clients that they take on. But then you wanted to legitimately have a T card and come back to campus, is that right? So you came back to U of T.
I did.
Yeah. So what motivated that?
I don't think I ever got over U of T kicking me out the first time. That's what I tell everybody.
Okay. We kept a desk for him. Is that it?
You guys call it graduation, but I saw it differently. I think I've always been attracted to the academic setting. I think there's something important about staying close to where a lot of thinking happens. In my time in the consulting space, you see a lot of applied approaches, principles, et cetera, that come from a lot of the work and research that institutions like U of T do. But I still wanted to feel close to the leading edge. There was a moment during my undergrad, Professor Marr from ECE, Helmi, when I was doing my fourth year project, I was doing it in laser diodes. Again, material science is fascinating from that perspective.
Underpins everything.
Underpins literally everything. And so in working with him, I think he planted a seed. He basically said if you wanted to do a PhD, you would be a strong candidate for it, just in how I was approaching my fourth year thesis topic. And that stuck with me. And I guess a part of me romanticizes the academic life as well. Right. Again, I watch way too much Good Will Hunting and like
you
Beautiful Mind
tweed
and
jacket with
with the
chalk
elbow
on
patches
and
and
chalk and everything. Yeah,
exactly.
Okay,
So I think a part of me was like, well, if at some point later in life I want to come back to the institution, this will be necessary. But at the same time, there's a lot of subjects that I saw within consulting that we obviously don't have the time, patience, or bandwidth to get deep in. And so I felt this would be an opportunity for me to pursue something like that.
So you should do kind of both at the same time, right? So you did, I guess, what we've called now a kind of a flex-time PhD or part-time PhD while you were working full-time. Is that right?
Yeah. So when I first started, I took 2 years off of work, actually. So I got through my coursework and I got through my quals, which I'm happy I did. I think to do that portion while I was still working would have been nearly impossible. And then the research just becomes sort of at your pace.
So I think this is actually a really attractive option. Increasingly now we're seeing people sort of graduate, get out, get some real world experience, and then think about, I'm going to come back, I'll do a master's, maybe a professional master's. Increasingly people coming back to do their PhD, because you kind of get a sense of, like you said, what you're interested in and where you feel the gaps are. And I love the fact that we now have this flex time option. And so did work keep a position for you? Or they knew you were going to come back in 2 years, or?
Yeah, no, they did not keep a position for me. I was not special enough.
Oh,
but
you kept the connections warm.
Kept the connections warm. And the thesis project came out of a project I was doing with Professor Mark Fox when I was at work. And so
yeah,
we were looking at if we could model the mechanics of innovation. And Mark obviously does, he's leading in the field of ontology design and that sort of thing from a computer science perspective, which was interesting. So we were working together for a client problem. And that's how that relationship began. And because I was close to U of T, you guys run in my blood, it gave me an opportunity to bridge that in my own world outside of the institution.
I just really like the fact that the university or the department, right, and actually the supervisors, right, and if you talk about, Mark Fox as your supervisor, sensing that opportunity, figuring out a path to make it work, kind of push the system a little bit, right, because there are these opportunities which show up and sort of explore new areas, right?
I actually give a lot of credit to Mark, also to Marcus Bosman,
yeah,
because they figured out a path for me prior to there being a formal industry PhD connection.
Yeah.
It's a lot easier now, obviously, because there's formal programming in place.
Right.
But at the time, this was unheard of.
Yeah. You need someone to be the trailblazer, right? You need someone to be the first person to make it work. And I think that's wonderful. So we talked a little bit about your thesis, and you mentioned the word ontology. So I know for the audience, it might be useful to sort of describe what.
Okay. So for the 10 people who really care about this.
11. I'm on the chat too.
So the thesis was essentially being able to measure the impact or the value of an idea and its likelihood to become an innovation. And how do you do that before something is like a priori? How do you do that before it's actually been created and built? Which makes it a data question as well. So if you don't have enough data and there's some ambiguity there, how do you start to infer what the consequences of the new idea or innovation will be? And to do that, we leveraged innovation-based ontology. An ontology is basically a taxonomy. It's all the connective points that describe a thing or a system. And in computer science, that's really important because for a computer to understand what a car is, it first needs to understand what a vehicle is and what wheels are and all that sort of thing. So when you start to expand across those things, you get an ontology. And so what my thesis did was it built an ontology for innovation. It then said, okay, now that you have all these components that you can measure, what are the core components necessary to predict whether an idea will be good or not? And then how do you then apply machine learning to that to be able to iteratively make better inferences?
Clearly, it's influenced which way you're going now, because you're still in the data science space. You're now in the AI space. Inaugural head of AI research at KPMG. As the first person in that role, what does it entail? What are your key focus areas?
Being first in anything is obviously a little scary because if it doesn't go well, there won't be a second. So what KPMG and the leadership there, Benji Thomas, who's our CEO, and Stephanie Terrell, who's the Canadian managing partner, what they have sort of bought into is the idea that as we move forward, the commoditizing of technology, so we buy a subscription to this, we buy a software tool over here, will eventually hit its peak. And in order to continuously find solutions, you're going to have to not only understand the domain of the problem, the industry, the sector, the client, which we're great at right now, but we're also going to have to understand what tools are being developed that can then be applied, tweaked, in order to create the value in the nuanced sense when everything else has been commoditized. So the role is to begin that journey. It means staying close to what's happening at our labs, at our universities, so that we can have a perspective of what's coming and how that can be applied. It means connecting and building partnerships. We cannot rely simply on let's wait until it's been, commercialized elsewhere. We actually now need to get in front of that. And quite frankly, personally, we know that Canada has a productivity problem. Everyone talks about it. It's a moment for us to not just talk about it, but to do something tangible about it. And if we are in a position to create the right fabric and the right environments necessary to start this sort of cross collaboration between institutions of higher learning, labs, clients, and ourselves who sort of hold a lot of that knowledge, the time is now, right? So let's put our money where our mouth is and move forward.
So does it mean your KPMG is building a lot of the tools in-house themselves? Is that one way to look at it, or?
Yes and no. There's a lot of tools and things that we will build, but there's a lot of things that will be much better suited through partnership. And so what we want to bring to those conversations is sort of the applied research, applied AI lens. There's going to be big parts of the academic space that continues doing discovery research for the sake of, where we have an interesting question and we're pursuing to find what the answers to those questions are. But there's also a growing desire, I think, across academics and others to really have someone come and say, listen, here's an area that would actually solve a problem today that we need your research power and capability to get an answer to, because my business as usual will not allow me to do that, nor will my limited expertise.
Right.
And so if we start creating those bridges, our thesis is that we will be able to offer more solutions that benefit society at large. We'll be able to give and provide more opportunities for very technical-minded Canadians or students in Canada who want to stay here and push that forward. And all in all, society will benefit from that.
Just like you did with Mark earlier. So when I was working full time, I had this problem. We got together as an academic group. Then you positioned yourself to do the PhD. This happens so frequently where it's a case of knowing kind of what is happening at the university, but then university at the same time, like knowing where the gaps are in industry.
And unless you have, I don't want to call it a mandate, but unless you are looking and you are creating these opportunities and you are comfortable hosting those conversations, a lot of that gap will continue to get missed.
One of the things is sort of, I mean, you do talk about staying close to U of T, right, besides using the library. So in this model where you'd want sort of people from industry to be with the university, is this a case of sort of, oh, let's have a coffee chat, or let's record a podcast? Or do you think it's something more deliberate?
I think it needs to hit across several layers. And to be fair, this role is 2 weeks old. We are still in a lot of the ideation and formulating what this is going to be. But this is why these conversations are important, because we're going to have to, I think, to do this effectively, have grassroots things like exchanges. Let's have some of our consultants sit within faculty. Let's have some of your students sit with us. Like let's actually start to create this pollination. But also, there's clients where we have a really good problem. Maybe it's still fuzzy. Maybe it's not been defined yet. And so part of that conversation is how would we define this so that we can actually create something around it? So I think we're going to have to hit all these different areas, sort of taking like a portfolio optimization approach, right? To land somewhere where we can see tangible benefit.
Slight divergence. I have to bring this up. I mean, and it is actually related to information, right? And this is kind of in the music realm. I mean, you're a musician, a composer. You know, how does that form part of your career and life right now?
So I'm retired from the music space. I did a lot of composing, performances, projects in that realm years ago. I did a lot of it actually when I first started my PhD as well. So it was like a nice little balance. But currently, I play for myself. I'm still heavily involved in the music community. But my joke is like to be a performer, it's a young person sport. And I'm happily no longer that young. So
we actually had a really strong connection between the faculty of music and engineering. We do have, probably not when you were an undergrad, we do have this certificate in music performance and certificate in music technology now.
Amazing.
That students can actually do while they are doing their undergrad. And I've had undergrads from my own group in chem, they had their ARCT in music when they were an undergrad, and they end up working for Dolby. So I think there's a lot of really strong connections.
I tell everyone, like, music is numbers. Harmonies are literal transformations. It's all numbers and math and information theory. And I mean, when you think about it that way, I guess for a lot of people, it doesn't sound as romantic. But if you understand what those concepts mean, I actually think it's even deeper, because then you start to realize that everything around you is music.
Yeah.
I think music and a deep appreciation for music helps you experience life with a kind of reverence that I think sometimes we can sometimes overlook. And as a practitioner, the one thing that I will say is that there's a certain discipline that comes to learning that music, I think, is very much transferable in a field like engineering. When you learn to play an instrument, you suck for most of it.
Mm-hmm.
Like, you're just awful.
Yeah.
Okay.
Yeah.
But if you stick with it and you're concerted in your efforts, you eventually get to see yourself become decent. And if you really stick with it, you can see yourself become really good. And being able to measure the output from your discipline to being able to create and to sound good, I think is very important in a field like engineering or any field that requires serious study. I remember I used to have the hardest time figuring out eigenvalues.
We all have problems with eigenvalues.
Okay.
I just put that out there. Eigenvalues,
the only one.
eigenvectors.
Yeah.
Yeah.
Very and I remember sitting in Goldstein for maybe 6 hours. And for the whole 6 hours, I really didn't know what was going on. And then 6 hour one, it clicked.
Yeah.
And I think for me, that's music. It doesn't, and then it does.
Right.
So
if you're out there listening, keep playing your scales because that's going to be important. Next thing you know, we'll ask people to submit a music portfolio in order to apply to engineering. We don't do that yet, but
that I would sit on that committee.
Awesome. You've stayed really close to U of T, obviously, and can you talk about some ways that you've sort of contributed back to the faculty and kind of engaged students? And
yeah, so I mean, a handful of things. I come in, I give guest lectures. About once a quarter, I will host students at KPMG, and I'll just let them ask questions, and I'll feed them. So if you want or are interested, shoot me a message, and we'll get you on the list. And then I stay close with faculty, so I talk to folks all the time, figure out what they're doing, understanding, see if there's areas to collaborate. I honestly credit University of Toronto for, in many ways, changing my life. And so it's really important to me to be around and to give back.
Yeah, I think it's wonderful. Thank you so much again for your supporting the students and being so engaged. So the classic last question, what advice do you give students who want to follow in your footsteps?
I think stay curious. If something doesn't exist yet, that doesn't mean it cannot be. Again, when I came to do my PhD, there was no mechanism for that.
Right.
We figured it out. This new role at KPMG, it's inaugural. It wasn't there before. Now it is. And so I think if you can take anything from my career up until this point, it's to stay curious, be creative, and don't let the lack of something determine whether or not it's a real possibility.
Yeah, there's wonderful advice. It's all about sort of, if you want to get the opportunity, create the opportunity, right? And there are people here to support you on your way and want to make that happen. And others will follow.
Absolutely.
And so you will not be the one and done head of AI research at KPMG. There will be a successor to you. But Andrew, thank you so much. It was awesome. What a wonderful conversation.
Yeah, thanks for having me. This was great.
Thanks again for listening to Tell Me More, Coffee with Chris Ship. If you want to catch up on past episodes and to make sure you don't miss the next one, please subscribe. We're on Apple Podcasts, Spotify, and more. Just look for Coffee with Chris Ship. You can also check out at U of T Engineering on Facebook, Instagram, X, and LinkedIn for more stories about how our community is building a better world. And finally, if you'd be inspired to join us, we'd love to welcome you. If you're thinking of taking a degree or working with us on our research projects, you can find us online at engineering.utoronto.ca, or you can visit our beautiful campus in Toronto, Ontario, Canada. I hope I can join you for coffee soon.